So I want to teach you a really neat trick that is super quick, and if you can essentially master it, you should be able to always identify the leading and lagging strand anytime you're given a replication fork or a replication bubble. So I'd like to show it to you with a replication bubble. So again, I'm going to draw my double-stranded DNA molecule. Here's my origin of replication. Here are my 3' and 5' strands, or I'm sorry, ends on each strand. And let's say that my replication bubble looks like this. Okay, so here are my origins, and there we go. So this is a multi-step process, but if you follow each instruction, it should be relatively easy to handle. So the first thing I want you to do is I want you to divide the replication bubble straight down the origin. So just do a dotted line or a solid line, whatever you need to, down the origins of replication. That's going to divide our bubble in half into the two replication forks. The next thing that I want you to do is I want you to draw two solid lines. One above that runs parallel to these two pieces of DNA, and then one below that runs parallel to these two pieces of DNA. On the top, I want you to write the 3' and 5' ends such that this piece is running anti-parallel to this top piece of DNA. So in this case, here's my 5' end, this is going to be my 3' end, and then here's my 3' end, so this should be my 5' end. For the bottom one, I want you to do the same thing, but it needs to run anti-parallel to the bottom strand. So here's the 5' end, so this should be 3', and then here's the 3' end, it should be 5'. So on one side it should go 5, 3, 5, 3, on the other it should go 3, 5, 3, 5. Okay, now these two purple pieces represent the new pieces of DNA that are being made by our polymerase. And remember, when polymerase synthesizes DNA, it always does it from the 5' end to the 3' end. So the first thing I'd like you to do is draw an arrowhead pointing at the 3' end of your new pieces of DNA. Then what I want you to do is I want you to go to the dotted line in the center, and I want you to draw another arrowhead that's facing in the same direction and is pointing at the dotted line. So right here, it's facing in the same direction and it's now pointing at the dotted line. Down here, it's pointing in the same direction and it's now pointing at that dotted line. So what this has done is this has now divided up each of our new strands at the origin of replication, and it's ultimately showing us the direction that the new DNA is being synthesized. So now we just have to ask a very simple question. So what you're going to do is you're going to look on each side of the origin of replication at these two lines, or these two lines, and all you need to figure out is the line pointing at the end of the replication fork, here, or is it pointing at the origin of replication? So notice down here, this is pointing into the replication fork. So if I drew it, it would look like this. Remember, if we're synthesizing DNA into the replication fork, that is the leading strand. This one up top, though, would be pointing away from the replication fork and at the origin. And as a result, this is going to be the lagging strand. Now, I'm going to come over to the opposite side, and I'm going to do the same thing. Now, if I wanted to draw in here just to show this, I'm going to get these Okazaki fragments. So, there we go. There we go. Okay, so let's go over here and do the same thing. This arrow here, if I draw it on here if I need to, it's pointing into. So this is going to be the leading strand on the right-hand side of the origin of replication. This one here, however, would be pointing away from the replication fork, and as a result, this is going to be my lagging strand. So notice, on each of our two new strands, we have one lagging and one leading. One lagging and one leading. Okay? And so this is a very quick way that if you're given a diagram, you can just very easily identify the leading and lagging strands in DNA replication.